and that would be my solution, either of those forms. New slide. This is the last of the new concepts, and then everything after this will be a review of what we did in semester 1. Okay, but this really is just continuing working with quadratic functions. Okay, so now we're shifting gears and talking about some algebra review. Okay, and I'm going to show you two methods of solving quadratic equations. Okay, and they're the first two that you should probably look to use. You can always use completing the square. You can always use the quadratic formula for any of these as well. But these are the ones that have special forms that you can, special process that you can use to solve it. So the first is to solve by factoring and then using the zero product rule. Okay, so what this tends to involve is you have multiple terms with variables. So you have an x squared and you have x terms. You have multiple variables. Okay, if that's the case, what you're going to do is you're going to move all the terms to one side of the equation. So when you hear me talk through these problems, what you're going to hear me do is like I approach it using the following. So looking at this first problem right here, we're going to move all the terms to one side of the equation. So they're already there. We have multiple variables or multiple terms with variables. We have an x squared. We also have x's. So move everything to one side of the equation, already done. You're then going to factor it. And so if I look to factor this left side of my equation, I'm going to be using the reverse FOIL process. The only two factors that give me my first term x squared would be x and x. And then what two factors of positive 9 give you a total sum of that middle term's coefficient, positive 10? 9 and 1, so plus 9 plus 1. So there's my factored form. I then move to my final step, which is the zero product rule. And I'll talk about that here, remind you of what that is. And the zero product rule says this. If a times b is equal to 0, then either a equals 0 or b equals 0. What that means is once you factor it and set your factors equal to 0, you're going to set each individual factor equal to 0 and solve. Those are your possible x values. And now, if you're not already comfortable with mental math, what you could physically do is you could take each of these factors, x plus 9, set it equal to 0, x plus 1, set it equal to 0, and solve. Okay, and so here we subtract 9 from both sides, and here we subtract 1 from both sides. And so we get our solutions negative 9 and negative 1. Those would be our answers. Now, if you are comfortable with mental calculations, what you can do to solve for these factors is you simply take the opposite of the constant and then divide by the leading coefficient. Now, this is of your binomial factors, and that's going to give you each solution. So the opposite of 9 is negative 9, divide by my leading coefficient, which is 1. The opposite of positive 1 is negative 1, divide by my leading coefficient, which is this unwritten 1 as well. So negative 9, negative 1 would be your answers. Okay. All right. So try the problem right below. See if you can factor that, set the factors equal to 0, and solve. So most students, when they are looking to solve this second problem, most students tend to see it in the same process as what I just did. You reverse FOIL. All of your terms are already on one side, so we're going to look to factor. The two factors that you can multiply to give you your first term of x squared is just x and x. For your last term, you need the two factors of positive 25 whose sum is negative 10. What does that happen to be? Negative 5 and negative 5, right? So if you do it this way, you set your factors equal to 0 and solve. So we take the opposite of our constant, positive 5, divide by our leading coefficient. Opposite of constant, divide by our leading coefficient. And we get 5 and 5, right? It's the same one. It's just a repeated solution, so 5 is your only answer. Right? If you have two of the same factors or solutions, just write it one time. Okay. Now, did anybody recognize this in, using a special pattern? So this is the sum of squares, right? It's a binomial square. So if you recognize that pattern, you could have just recognized that it's x plus 5 squared equals 0. And if that's the case, you'd still, x minus 5. You would still wind up with the same solution, x equals 5, but you might factor it slightly different. You can use any special factor forms that you might see. Okay, so try this one right here, since it has that same pattern, or it has another special factor form that you could solve. Okay, but there's two different ways that you can approach this problem. I'll talk through both of them. So if you recognize this as the difference of squares and you factor it, that would be following these rules. Here, all the terms are on one side. However, notice there are no multiple variable terms. There's only one term with a variable. Okay, so my general rule for if you see an equation where there's only one term that has a variable, we're going to solve it using what's on the next slide. So again, probably I'll go through the second method here in a moment, but I would probably approach this using a slightly different method. But if we are factoring this, if that's what you see, you would recognize it fits the special factor form of the difference of two squares factors into the sum and difference of the terms being squared, right? A squared minus b squared factors into a plus b times a minus b. And if that's the case, then you have the base x and the base 3. Oops. So if you have the difference of two squares here, you have x and 3 are your terms. You take the sum and the difference of those, set each factor equal to 0. You get a negative 3 and a positive 3 as your solutions. Okay, now, I mentioned before that the checks that I use for these is, when you're solving an equation, always look to see, are there multiple terms with variables or just one? If there's only one term that has a variable, isolate that variable. So what I would do on this problem right here is I would keep my x squared where it is, but I'd move 9 to the other side. Okay, and then you're going to do what we'll talk about on the next slide, which is called extracting the square root. If you take the square root of both sides, you need to take into consideration both the positive and negative root. Square root of 9 has a value of 3, and so notice we have negative 3 and positive 3, two different solutions here. So that would be the other way that we're going to talk about on the second slide. All right, so I want you to try these remaining two questions here, the top and bottom one. These are the ones that are a little bit harder, okay? But see if you can find the solutions to those by factoring, setting the factors equal to 0 to get your solutions. All right, let's look at this top question. Okay? The problem, or this type of equation right here, tends to get students missing some answers because a lot of times what a student might think is if you divide both sides by 8q, you can simplify the equation. But in doing that, you also wind up getting rid of one of your possible solutions. Okay, so you don't want to do it that way. Think about it using these rules. Do you have just one variable term or do you have multiple terms with variables? You have two, right? So let's move them all to the same side. So we want to move it to the side where the leading coefficient's positive, so we'll move everything to the left side. Right, if you don't do this, you are likely going to miss one of your possible solutions. Okay, and so the next step is to factor. So when we factor this, we're going to look to remove common factors from both of these terms. So numerically, between 8 and negative 24, you can remove a factor of 8. And then from the variable terms, you can remove a q to the power of 1. When you then look to see what's left, when you remove an 8q from 8q squared, we're left with a q for the first term. When you take an 8 out of negative 24, we're left with a negative 3, take the q out, and that would be the remaining factor. So now we have our factored form. Now we can set each of these factors equal to 0. Okay, and so anytime you have a monomial factor with a variable set equal to 0, it corresponds to a solution of 0, right? If you took 8q equals 0, divide by 8, you get q is equal to 0. But any monomial factor with a variable is always going to correspond to a solution of 0. And then if we use our rule, take the opposite of our constant, positive 3, divide by our leading coefficient, 1, and that gives us our second answer. So there would be our solutions. Again, the trick to this one is to remember to put all the terms on one side and then solve by factoring. All right, the trick to this last question is just that you have the trinomial with a leading coefficient of something other than 1, and so you either need to use trial and error and reverse FOIL it, or you need to rewrite the middle term and factor it. So here we have multiple terms with variables, so let's move everything to one side. We'll add 13x to both sides here, set it equal to 0. And so you can either use trial and error here and find the different combinations to reverse FOIL, or again, my preference is to rewrite the middle term. If you're rewriting the middle term, these are relatively small and easy to use numbers. And so 2 times 21 is take the product of your first term and the leading coefficient and your constant. You get 42, positive 42. And then we're going to find the factors of this whose sum is the middle term's sum, positive 13. So we know it has to be an odd number, right? 13 you can only add up to an odd number if you have an odd number. So we're going to look for an odd factor of 42. So we could try 3. Like if you think about 42 is 3, and when you look at that, 14, does that have a total of 13? No. So let's pick another odd number that's a factor of 42. 5's not. Let's go 7. 7 and 6, do those add together to give you 13? Yeah. And so what we're going to do is we're going to rewrite our middle term as the sum of those, right? 7x plus 6x. Drop our first and last terms down. And then we're going to solve or factor by grouping. So from the first pair of terms, we can remove a common factor of x, leaving 2x plus 7. From the second pair of terms, we can remove a factor of 3, leaving 2x plus 7. If we've done this correctly and it's factorable, we should have a common binomial factor, which we do. We take that out. And then the remaining monomial factors of x and positive 3 are going to form the terms of your other binomial. So here's our factored form. And if you did trial and error, this is the set of factors that you would test and get to have a FOIL expanding form into the 2x squared plus 13x plus 21. And so now you can see the rules that I talked about for solving. Take the opposite of the constant, opposite of positive 7 is negative 7, divide by the leading coefficient 2. So negative 7/2. The opposite of 3, divide by the leading coefficient 1. And so those would be your two solutions for that. All right. So again, like these are the types of questions that you need to be able to solve by factoring. Okay, I'm going to go through. I know it's a lot on this first day back. Sorry about that. Tomorrow's should be relatively short, and you'll have plenty of time to work on this homework too. Okay, but let's look at this last slide. And this happens when you look at the original questions and all you see is one single variable, but it's still a quadratic equation. It still has a power of 2. Okay, so if that's the case, you're going to isolate the variable term. Okay, it might be as a single term, or it might be as a binomial. Okay, so a problem like this right here, if we isolate, we notice there's only one variable term here, so we're going to leave 2x squared, add 98 to both sides. We can continue to isolate our variable, so we divide by 2. And once you get to this point, then you can extract your root. And the thing to keep in mind here is you always need to take into consideration the positive and negative root. Okay, so here when we extract the root, we take the square root of both sides. Anytime you take the square root of x squared, you have to consider both the positive and negative of that root. Square root of 49 is 7. And you're just going to enter your answer as a list of numbers. All right, so try this bottom problem right below it. Okay, see if you can answer that again. It's pretty straightforward. You recognize you have just a single variable term, so we isolate that, divide both sides by 4, giving you p squared is equal to 9 over 4. Extract your root. When you extract the root, you have to consider both the positive and negative root. So the square root of 9 over the square root of 4 gives you 3 over 2. So negative 3/2 and positive 3/2 are your solutions. All right, this last one I just want to again talk through. This would be the harder of these types of questions. Okay, and that is, for a lot of times students will look at this and they'll think, expand this binomial square, multiply everything out, combine all your like terms, and then solve by factoring. You can do it that way, but this is already set up where you have just a single variable. If you notice that there's only one variable in your equation, even though it's part of this binomial square here, that's still fine. Look to isolate that. So we isolate this by dividing both sides by 3. And then we extract our root. And notice when we take the square root of both sides, we have to consider both the positive and negative of that root. And root 6 does not simplify. It's still just left as this irrational number. Okay, and that's fine. You're going to leave it that way anyway. Add 5 to both sides. And that gives you your solution, 5 minus root 6 and 5 plus root 6. And you're just going to list your answers as each of those individually separated by the comma. If you tried to do this by factoring, it would not work, and you'd need to use either either completing the square. If you expanded everything, you would need to complete the square or use quadratic formula, which will lead you to this answer. But again, it's not going to get simpler than it already is when you see that you have just that single variable in the equation.